Hi everyone, and welcome to today's seminar for the ARC Training Centre in Predictive Breeding. Before we go too much further, I'd like to acknowledge the traditional owners and their custodianship of the lands on which we meet today and pay our respects to their ancestors and their descendants who continue cultural and spiritual connections to country and recognise their valuable contributions to Australian and global society. So this is the second ARC Training Centre seminar, and it's a really exciting one on a very timely and important topic as International Women's Day approaches this Saturday. And to introduce myself, I'm Dr Millicent Smith. I'm a senior lecturer in crop physiology at the University of Queensland, and I'll be the facilitator for today's session. So it's my absolute pleasure to introduce Professor Jennie Pryce, who's the Deputy Director of the ARC Training Centre and a Research Director and Professor at Victoria and La Trobe University. So from her early days breeding Holstein dairy cattle in the UK to becoming a real pioneering force in genomics and animal breeding, Jennie has really transformed the way that dairy herd improvement is approached. And her groundbreaking work through the Dairy Bio program has delivered tangible benefits to farmers across Australia and the world, really helping create more productive and sustainable dairy systems in the face of climatic changes. Her excellence has been recognised globally, becoming the first non-American to receive the prestigious J.L. Lush Award from the American Dairy Science Association, and for being consistently ranked as one of Australia's top researchers in animal husbandry. I think as we approach International Women's Day, I wanted to mention that I'm really inspired by Jennie's leadership, and she really embodies what's very possible with science excellence and really meets this genuine commitment to industry impact and creating pathways not just for dairy advancement, but also for the next generation of women in agricultural science in particular. So please join me in welcoming Jennie.
Thank you so much for the very generous introduction. And it is a very uncomfortable topic, I think, when you're being asked to talk about your own journey. So I would much rather be talking about the science, but today you're going to hear about my story, and I'm very happy to talk about it. It's actually taken me a lot longer to put this together than it would for a normal science presentation, and I think that's because you have to think so much more in terms of the messages that you want to get over. So I hope I do it justice today. I would also like to start by acknowledging the traditional owners and the custodians of the land and water on which we meet today across Australia. I'd particularly like to mention our friends in Queensland. We are really thinking about you right now with the challenges that you have with the storm coming through. I am talking to you today from Bunurong country. Our sea is very calm today down here. I think I really relate to the Aboriginal people in terms of their custodianship of the land and their genuine connection and how they have nurtured that for thousands and thousands of years. And I don't say this in a frivolous way, but I would like to think that my ancestors have done very much the same thing, but on the other side of the planet. As far as you go back on any of the kind of lines of my family tree, you'll find farmers. These are British farmers, either in England or Wales. I'm very humbled to be a descendant of these, my ancestors, and the things that they have done to nurture the land on which I grew up. I'd really like to mention in particular Edward Salisbury Pryce, who's my great-grandfather, and he actually purchased the farm on which my family now have and look after for the generations to come. I did 23andMe, as many others have, just to try and discover some interesting things about my ancestry. But I think it goes without saying that I'm pretty British. And I could have found that out from tracing my pedigree and my ancestry, but it just goes to show that, I'm basically British origin, and it's a very tight part on the English-Welsh border. My family, apart from me, didn't travel very far. So this is the farm on which I grew up. This is the farmhouse that Edward Salisbury Pryce purchased. He was in debt for most of his life to be able to afford this property. Thankfully, The land is no longer in debt, and it's a beautiful part of the country. You can see it's situated here, but beneath Liverpool, and you can see the Welsh hills on one side, and on the other, it's literally England. So it's very much part of that English-Welsh border country. Now, when I was a kid growing up, we had black and white cattle. My brother Ben has always been an enthusiast of growing forage crops, and he wanted to have a Jersey farm mainly because he really believed in growing high quality forage to feed to his cattle. So that's what he did. Unfortunately for him, he had a very seasonal system, so very similar to the kind of systems that we have here in both Australia and New Zealand, and he couldn't get a milk buyer that made financial sense for him. So now he looks after chickens, and they're broiler chickens, and we no longer have dairy cattle on the farm. But I guess it has been a really incredibly important part of my life to have grown up with dairy cows, and I became, I guess, a genetics enthusiast from a young age. And I asked my dad recently if he could remember exactly what age I was when I first announced that I was going to become a geneticist. And he said I was about 11 years old, so probably around about this kind of age that I'd already made up my mind. I didn't know exactly what it meant at the time, but I had absolute conviction that that was where I was going to end up. My dad very generously gave me my first cow, who's the Seven Vale Baron Ember, and this Seven Vale prefix was my pedigree herd of Holstein cows, and you can still search for them in the UK Holstein database, so they're still there, which is kind of cool, I guess. So yeah, so I was inspired to become a geneticist, and the next stage for me was to actually work out how I was going to achieve my goal. My career has got three distinct chapters. The first was my time in Scotland. I did my undergraduate degree and my PhD in Edinburgh. Then I moved to New Zealand, and from 2008 I've been based here in Victoria in Australia. Now, the reason why I decided to move to Scotland from the English-Welsh border was, you've guessed it, because there was something that really captured my imagination in terms of dairy cattle genetics going on there. And that was the Lang Hill herd, which was based in Edinburgh. And it was a long-running selection experiment of high and low genetic merit animals split between two feeding systems. And it was absolutely unique in the UK. This long-running genetics research program that was in dairy cows, it was an absolute no-brainer for me in terms of where I was going to go to university. While I was there doing my undergraduate degree, I met probably one of my first, actually my first academic mentor, who's Professor Jeff Sim. He was in charge of the Lang Hill experiment at the time, and I actually got a summer holiday job working on the farm, which I thoroughly enjoyed. And through that time, I got to really know the team and the researchers. And Jeff was so kind in actually developing up a PhD project for me that exactly fitted with my interest. So I did a PhD on the genetics of health and fertility in dairy cows. Now, what I didn't realize at the time, for me, Jeff was the person when it came to dairy genetics in Scotland, but he had as my Edinburgh University supervisor the late and great Professor Bill Hill. And in terms of people who have had a massive impact in animal breeding and genetics, actually genetics full stop, Bill was one of the absolute greats then, so privileged to have had these two guys as my PhD team, in addition to Robin Thompson and also Rule Camp, who are both incredibly prestigious supervisors as well. So I pretty much sat in my PhD meetings just watching my supervisors argue amongst each other. It was pretty cool, and in retrospect, it was an amazing a situation and environment to be in. So I thought I'd just put up this, which is my Google Scholar citations and papers, most cited papers, just because I wanted to make the point that the papers that you write in the early part of your career may end up being the most impactful in terms of your complete career. I've put the Union Jack beside the papers that I wrote during my time in Edinburgh, and you can see that they're still, 4 out of my top 10 papers that I wrote in the UK. And you can also see, and I'm very humbled to have like the co-authors that are listed here. It's pretty amazing just to take a step back and look at it. And I guess I was known as the health and fertility person. So a lot of my papers, still my most highly cited papers, are within this area of research. So genetics of health and fertility of dairy cows is still one of the things that I guess I continue to be well known for. What also happened at the same time was that I got, I think, probably by good fortune, because I was doing my PhD in health and fertility in dairy cows. At that time, in the late 90s, early 2000s, there was a global network that was set up to work on genetic improvement of functional traits. So I got to be part of that from when I started my PhD. And having that network of, I would call them lifelong allies, has been really, really important. Not just allies, but actually really great friends. So a lot of my greatest friends are people who come from the animal breeding and genetics community. So it's a really important part of me and who I is to have had these amazing networks of people. This opened the door to becoming part of the International Committee on Animal Recording working group for functional traits, and I joined that at its inception, which was in the early 2000s, and I've only just relinquished my role as part of that working group. It's led by Krista Egadan, and I would consider, the people on the image here to be good friends as well. Really important part. Those networks and where the doors that they may open, I think are really, really important. So one of the, I suppose, not so nice things about my early career was that I cannot remember the number of times where I had people actually openly criticize me, mainly out of the area of genetics. So the, people who were in other areas of science who would say, look, there's no way you can improve health and fertility traits through genetics. You've shown us that the heritabilities are low. Genetic selection just simply won't work for these traits. And I think one of the things that I've said right from the beginning is that even though the heritability of these traits is low, the genetic variation is quite often very large. And I think one of the greatest demonstrations of how genetics can lead to an issue in an industry, but also its recovery, is what's happened to the genetic trend of fertility. And I'll use an example here of Australian breeding values. This decline here of fertility breeding values almost happened without anybody noticing it. It was due to single trait selection for the milk production traits, and it led to a massive deterioration in fertility. This is the time actually that I was doing my PhD here in the late 90s, just when we were about to reach the plateau. We didn't have a breeding value for fertility in Australia until the early 2000s. But I think it's really gratifying to see that through having a fertility breeding value, we've seen a resurgence, and it's actually very pleasing to see that the slope of the improvement is much steeper than the slope of the decline. So genetics absolutely works, and fertility is still an area that's of concern to dairy farmers, but it's by no means as bad as it would have been if we'd have continued to have gone in that free fall trajectory that we were in through the 80s and 90s. So While I was still at Edinburgh, Bill, and I distinctly remember the conversation with him that he said, look, you've done your undergrad here, you've done your PhD, now you're starting to do a postdoc. Have you thought about working somewhere else for a while? And he actually commented many years later that he didn't expect me to spread my wings quite as far as New Zealand and Australia, and that he thought that I would always come back. But here I am many years later in Australia. So New Zealand was my first stop down under. I arrived in 2001 to the Research and Development Group at LIC, which was a fantastic experience. I learnt C++ programming. I also learnt a number of other programming languages, which has really set me up well. Very inspirational group of researchers who continue to work there. And actually the group has grown considerably since my days at LIC. So it was a fun time and lots of really good projects that I became involved in. So of course I was involved in fertility breeding value, genetics of body condition score. I got my first taste of developing, a management tool. So I did an inbreeding control strategy, which we actually called BRAT, or the Bull Roster Assistance Tool. I was involved in the strain trial, which was with Dairy NZ, or Dairy New Zealand, and that was very reminiscent to the Edinburgh trial, where we were comparing high and low genetic merit cows, except the strain trial in New Zealand was doing an additional comparison to 1970s animals. So there's 3 different lines there. And of course, while I was there from 2001 to 2008, towards the end, we were starting to do R&D to implement genomic selection. So the industry exposure was great. And the fact that I was doing research that had direct impact to New Zealand dairy farmers was also really exciting. But I have to say, one thing that was missing from me, and I guess this probably echoes back to earlier in my talk, was I actually missed publishing papers, and you won't see any of my highly cited papers being from that time in New Zealand. So I was looking for the next step and where I could go next. And one of the pieces of work that we were doing was we were starting to do some work with Australia on measuring feed intake in growing heifers. And at this time, I had the great honor of meeting Ben Hayes for the first time. And I guess I was really excited by what Ben, Mike Goddard, and others were doing in terms of genomics in Australia. And I thought that would be a really great fit for me. Now, my partner, Olivia, was also, we were together, we'd been together for quite a few years, and it was actually a really good fit in terms of there were great opportunities for both of us. And we were excited by the prospect of living in Melbourne. And what Olivia didn't realize at the time was there was a bit of an ulterior motive to moving to Melbourne. And that was, I've always been a tennis nut. And the thought of spending a couple of weeks at the Aussie Open every year was yet another incentive to up sticks and move to Melbourne. Anyway, it's been, I think, an amazing journey to be part of with what we've achieved here in Melbourne. And of course, we had Ben with us for the first few years before he headed up to Queensland. But this basically summarizes the impact that the team at Agriculture Victoria Research have had on the Australian dairy industry via DataGene. So the partnership with DataGene through the Dairy Bio Initiative, which is a joint venture that involves the Victorian State Government, Dairy Australia and Gardner, has been really important in terms of increasing the rate of genetic gain, mainly through the introduction of genomics, but also, I think one of the things that we have worked really hard on is to improve the uptake of breeding values and get farmers to really believe in what we are doing and delivering. So it's been a very gratifying time, and it's really nice just to take a step back and review and look at what we have achieved. So after we introduced genomics, we established a female genomic information nucleus, which has been essential for developing breeding values that we rely on a dedicated population of animals that have both phenotypes and genotypes. For example, heat tolerance, which is a genomic only breeding value. The feed safe breeding value was one of the, I suppose, the first and one of the most important things that I feel like I've worked on. And I'm going to come back to that in my next slide, because that's one area where collaboration and global collaboration was critically important to make it successful. One of the most recent things that we've done is that we've released a sustainability index, which gives farmers an option to reduce methane emissions through using the selection index. So we've had 3 phases of research, from Dairy Futures CRC and 2 rounds of Dairy Bio, and I'm humbled by what we have achieved so far as a team, but also really excited to see where we can take the industry and into the future. And I think there are still many challenges where genetics provides an excellent solution. For example, we've only just scratched the surface in terms of the role of genetics in the sustainability index. Now, one of the hallmarks of my career has been these global collaborations. This is a photograph of what was called the Global Dry Matter Initiative in 2013. And we literally sat in a room in Wageningen in the Netherlands, and we put together a global data set of dry matter intake. Dry matter intake, or feed intake, is only available or only possible to do in reasonable numbers, mainly in research herds. So we were literally bringing together the data from our research herds. Mike Coffey over here brought across that Lang Hill data. And this is Roel Veerkamp, who is actually one of my PhD supervisors, but now based in the Netherlands. To my left is Mario Carlos, and over here on the right side is Donna Berry. And I was so lucky that I actually, many years later, 10 years later, was standing up together with those 2 guys, delivering the opening keynote of the World Congress on Genetics Applied to Livestock Production. So really amazing photograph in terms of the people here and the significance that they have had in my career. So this was 2013, and I want to take you a few years later, and Millie actually kindly mentioned this in my introduction. In 2016, I was only the 2nd female and the first non-American to be awarded the J.L. Lush Award for Animal Breeding and Genetics from the American Dairy Science Association. Now, I have to say that the citation, I don't know who wrote it, but it's incredible. And at the time, I think I was really suffering from imposter syndrome, because I didn't really celebrate this achievement, and I didn't really feel like I genuinely deserved it. I felt at the time that they thought they needed to give the award to a woman because there were so few who had received the J.L. Lush Award. Now, I don't think that now, but I think reflecting on it, that's one of the things that we really need to work on. And I'm not just saying women, but I'm also saying us as a scientific community, because that kind of thing is not okay. I'm really comfortable with it now, but I would have loved to have celebrated it properly at the time. Now, this was actually, I did get the award only a few weeks before my daughter was born, so there was a lot going on at the time. So yeah, it was a very cool time in my life, but also, it would have been lovely to have reflected properly. So that was 2016. Now roll on to the current day. And I'm currently Research Director of Genomics and Cellular Sciences as part of Agriculture Victoria Research, with 3 disciplines: molecular genetics, molecular phenomics, and computational biology. And I'm also a professor at La Trobe University. Now, in terms of gender balance, I'm really proud to be part of the executive leadership team of AVR. I'm actually really proud of all the things that we do and the leadership that we have here within AVR. We're led by Simone Warner, who I find very inspirational in terms of her leadership style. And I'm very humbled, I guess, again, to be part of this leadership team for AVR. Now, within AVR, and I'm not going to go into too much detail, but I just wanted to give you a little bit of an idea in terms of what we do and how we're structured. So we've got the 6 research directors, if you include Jodie in that as well, who's our operations manager beneath Simon. And we actually work across farms and scientists who are based across Victoria. So we have a number of different smart farms. Many of you who are involved in the grain side of things will be aware of our Horsham Smart Farm, which holds the Australian Grains Gene Bank. We also have a smart farm in Mildura, which is focused on temperate nuts and table grapes. We have one in Tatura, which is also for perennial horticulture. We have our Allenbank Smart Farm down in Gippsland. And we also have a sheep farm or a high rainfall farm where we do a lot of our pastures research. So it's our forage innovation precinct over there. But the hub in the middle is our AgriBio centre here. So we have roughly 400 staff, over 70 students. 45% of our staff are regionally based and 55% are based at our AgriBio centre here. So this is where Millie is today, in one of the meeting rooms here in AgriBio, and it's an absolutely stunning building and a fantastic facility for us to have. In terms of my team for Genomics and Cellular Sciences, what we do is we do a lot of next generation sequencing. We do basically anything that moves, so dairy, grains, horticulture. We do medicinal cannabis, metagenome of soils, animals and plants. We have our BASC, scientific computing. We've just had a multi-million-dollar upgrade, and the team just only on Friday using the brand new resource that we have there. We also have amazing capability in metabolomics and proteomics, which I think is really important in terms of bringing together the pieces that we have across different species. We do some work in medicinal agriculture, but our main focus is dairy genetics in both forages and animals, and that's where most of the team work. One of my roles is being a PhD supervisor. It's something that I really enjoy and value. I wanted to just give you a bit of an insight into 2 of our most recent graduates. So here you have Fazelle and Boris flanking me in the December graduation of La Trobe Uni. Boris worked on feeding behavior and rumen microbiome and looking to see how that affects methane production in both sheep and cattle. And Boris was awarded the Nancy Millis Medal from La Trobe University for the quality of his thesis. So very proud of him, but equally proud of Fazelle Almazi, who used sensor technology to study livestock welfare and production. And he found that discovering that longer grazing times in merino sheep are linked to higher parasite infection. Now, we're super lucky that these 2 scientists are now employed by Agriculture Victoria Research. And they're working on a project to selectively breed dairy cows that produce lower methane emissions while maintaining production, health, and fertility. So I am really passionate about what we are doing in the ARC Training Centre. And one of the images that we created as part of the research proposal was the synergy that we have between both animals and plants. And we've obviously seen a lot of the genomic prediction models, and actually a lot of people migrate from the animal side of things to particularly plant agriculture. But I'm really excited that this ARC training centre actually gives us so much in terms of synergy and the potential to use some of the models across both plant and animal examples. And I think a really good example of that is actually the G by E by M modeling, which is very standard in the plant side of things, but less a feature in the animal side of things. And I do think that these sorts of models are going to be very important for tackling methane emissions, for example, where we know that there is a very big sensitivity to the environment in terms of the amount of methane that is produced. We do have two projects that are available at Agriculture Victoria Research. One of them is on modelling G by E by M, and that was with a specific focus on feed efficiency, but also encompassing methane emissions in dairy cattle. And we also have another one on integrating phenomics to predict dairy cow health. So if you're interested, please either take a screenshot or feel free to contact me, or ideally Kendra afterwards. So Kendra takes care of our PhD students and is our education manager. Now, I'm not going to mention too much in terms of International Women's Day, but I do think it's important that we talk about this. We celebrate achievements and the accomplishments of women. It's important to raise awareness because there's still examples of gender inequality and challenges that women face globally. Just this morning, there was a DEEC webinar that focused on some of the quite horrifying stats in terms of inequality and inequity in financial situations. So it is a call to action day. It is deeply rooted in terms of our history. But the thing that resonates with me is that kind of global solidarity. That this is a day when we can bring together people from lots of different backgrounds to support women's rights and gender equality. The other thing I wanted to mention, because it's coming up very soon, is Cultural Diversity Week as well. And I want to acknowledge the importance of March for, in particular, our Muslim community and everybody who is fasting this month. And I think this is also a really important thing for us to do, is to look and honor the cultural history of those who are around us in terms of coming from different backgrounds. And even here in Victoria, we have around about 290 different languages from 314 ancestries. So Cultural Diversity Week is a time to celebrate this. So that's coming up soon. And it would be, I think, really remiss of me to not bring up this flag as well and to talk about inclusion in terms of people from different backgrounds in terms of the LGBTQI population. Now, if you actually Google inclusion flag, this is the one that actually comes up, which I think is pretty cool. And I think this particular slide here is something that everybody should be aware of in terms of the things, the actual meaning behind the flag and why there are so many different colors in there. So I think it's really important. And, you know, the people who intersect, so say, for example, queer Black people and people of color, that is where the biggest challenges still lie in our society. Now, why is all of this important in terms of what I've just been talking about? And I think one of the reasons is that you actually have to see it to believe it. And I am a very proud waver of this flag. You know, I have a wife and a child, so it's really a very important part of my life and who I am. And I would like to think that I am an important role model for this particular area. But I also wanted to bring you back to tennis as well. And you may wonder why I have a photo of Dylan Alcott up here. Now, Dylan Alcott is one of the most celebrated tennis players in Australian history. He happens to be in a wheelchair. He would not have got into tennis if he hadn't seen somebody at his local tennis centre playing in a wheelchair. That's a true story. I think it's incredible. And you have to see it to believe it, even the greats like Dylan Alcott. Now, the other thing, and the other person that I really wanted to talk about was somebody else who I have followed for very many years. Before I get to that, I just want to go through a few things. So you need role models to inspire. You need mentors like mine with Jeff, for example, to provide guidance. You need diverse teams to provide creativity and diverse opinions. You need networking and collaborations to generate new ideas and to actually make things happen, as we did with that Global Dry Matter Initiative. So all of these things are really important. But now I wanted to bring your attention to somebody who I have always admired, who has had many challenges in her lifetime and has come through it admirably. I first met Temple Grandin, or I should met is probably an exaggeration, saw her speak about 10 years ago in the USA. And she was utterly inspirational in her advocacy for both autism and animal science. The things that she has done in terms of providing solutions for animal science, incredible. So around about 50% of US cattle that are slaughtered every year, done so using some of the things that she developed. Now I am going to show you a video, a short excerpt from the movie Temple Grandin, which was released in 2010. If you haven't seen this, it's really well worth watching. I've just watched it again this week in preparation for this talk, and I thoroughly enjoyed it. The clip I'm going to show you is from 2 bits of the movie that have been squished together, and I think it kind of reflects a very positive side of her. Oh, here we go.
So, Temple, will you put some cattle through your dip while I'm here?
Okay. So if the handlers walk slowly clockwise outside the chute, then the cattle walk counterclockwise through the chute. And they're happy to follow a curve. They're okay because it's grooved and they know they won't slip.
Miss Grandin, this is a masterpiece.
It'll take us forever to get them through here. Look at this. I mean, look at that. Who'd build something like that? Just give me some sheet steel. We're gonna slide these puppies in here.
Rick, where's that sheet steel?
Let's go get them up. Put them over in that pile and get them out of here.
She's here.
Y'all keep working, boys. I'll take care of her. Pick it up.
Could have seen this coming. Man.
Some dip you got here.
Who put steel on that slope? Cattle can't walk on steel.
We just had 3 head drowning here.
That's your fault. You killed them because of your stupidity. And why are they coming through the curved chute?
That'd take us all day, little lady.
Put it all back the way it was. They killed 3 cattle because of their stupidity.
I think you'll all agree that that slide is basically the good, the bad, and the ugly. It's a very confronting movie to watch, but I do hope you do see it. I was hoping that I'd have a little slide before this one because it's kind of an awkward jump now to talking about my family and the support that they have given me. So my partner Olivia and my daughter Sophie. And I would say, and I don't say this lightly, but I think until you become a parent, or perhaps many of the parents will recognize this, I feel like I've learned more about myself in the years that we've had Sophie, she's 8 years old now, than my previous life. And I think life is so much more richer for that. But I really do think that she's been my greatest teacher so far. So it's, again, a really important life is to bring your whole self to work and just to be as genuine as you can. And I certainly, couldn't say more in terms of the contribution and the support that I've had from my family. So to summarize, follow your dreams. I mean, this is, for me, it worked. It doesn't work for everyone, but I think you can follow your dreams, but you have to follow it up with conviction, dedication, hard work. The thing that's really helped me, and I'm very lucky to have been those collaborations. I've really nurtured those throughout my career. So it, again, dedication and hard work to make those actually happen. Also, being willing to juggle many projects. And that's something that those factors have really, I think, when I've sat down and really thought about it, have all helped me to succeed. Now, I hope it's come through loud and clear in my presentation. I really do believe in diversity in all different ways that you can think of it. And I do already think that we've done a good job in our field, and we need to celebrate our diversity, but make sure that we continue to make progress here as well. So International Women's Day is important. So are all of those other events that also celebrate diversity. So our collective success into the future requires breaking down barriers and making sure that we're willing to work together. And I do wholeheartedly believe that the ARC Training Centre is a very important part of this. So to finish on, when we support each other, we really do all rise. And thank you very much. It's been an honour to do this presentation. I hope that you found it useful.
Thank you, Jenny. I wanted to ask a question as well, as since I have this
Sure.
this honor. I think you mentioned a few times that your work is a really significant part of who you are, which I think resonates with many people who are in academia. But we often get this conventional wisdom that we shouldn't define ourselves by our work. And I guess I'm curious how you navigate this tension. You mentioned a little bit about your personal life too, and how you have this maintain a healthy separation, or potentially not, between your personal and work life.
I think it is, it's a really good question, and I don't think there's, kind of a great answer to it, but I do wholeheartedly believe, I think I said it in terms of bringing my whole self to work, but, it kind of goes both ways, that I am also the work that I do. And many of my friends come from, this area of research because we have that common interest and common goal. So it's kind of natural. And I think, when I reflect on people who I kind of naturally gravitate towards, they are the ones who have a naturally more curious mind. So probably more of that scientific. So it's hard to escape it, I think. I think it's always there.
Yeah, that makes sense. Okay, so some other questions. There's one from Mulu from Purdue University who says, it's midnight here and I'm really enjoying your talk. So thank you for the great talk and for sharing your experiences with genetic improvement in cattle. I'm interested to hear your thoughts on how automated phenotyping data recording tools might influence the future of genetic improvement in dairy cattle breeding.
I think it's such a critical part in terms of getting right, and to be able to provide us with, novel ways of measuring probably many things that we haven't even thought about before. So an example of that, one of my PhD students, Laura Jensen, is working in this area. There are devices that you can have on cows that are able to evaluate how well they're tolerating hot and humid conditions. And I think that sensors are going to provide us with much more, a massive volume of quantitative data that's going to help to develop breeding values that are going to provide, solutions into the future. So heat tolerance is an easy one. Fertility in dairy cows is also an easy one, because most of those devices do already detect estrus, for example. But I think the exciting part comes to, us being able to put our diverse minds together and come up with those novel solutions that really require the out-of-the-box thinking. And there has been, some effort in this area already, but I really do genuinely think that we're only just starting to scratch the surface there.
Yeah. So there's a nice question from Michelle that says, thank you for sharing your genuine and special story. Wondering, how do you approach your risk-taking, both personally and professionally?
It's a really good question. I'm quite a cautious person when it comes to risk, and I think, yeah, I am and I'm not. I think it's important that we take risks, and perhaps, they are well thought out risks that we do take, because a lot of them, they've been kind of hallmarks of my career so far, have been risky things that we've embarked on. But ultimately, I think the benefits that have come through them have been really important. So it's important to, have risk. That's the foundation, I think, of good science. And it's the way that we're going to make these major breakthroughs. So we do need it. I really do think that it's one of the models that we have here at AgVic Research, and it's worked really well, is that many of our most risky projects are the ones that we have for PhD students. And, those sometimes lead to research areas in their own right. So, for example, Tim Luke, who did his PhD with me a few years ago, we looked at biomarkers of dairy cow health. And, one of the concluding remarks of his thesis was that we need to do this on a much bigger scale. And we actually had that as a project that went into the main part of the Next Dairy Bio program. And now we have over 10,000 cows with these health biomarkers. And, if we weren't prepared to take a risk and have a look in that PhD, then, we never would have got there. So I think it's a good model, and I think it makes for the most creative and interesting PhDs by having that there as well.
I think on the question of scale, there's another question in the Q&A box about the role of satellites in phenotyping cattle for the future. Do you have any thoughts there?
Yeah. Again, I think this is another example of, potential out of the box thinking that may be really useful for the future direction of animal breeding. Satellites, you can think of them that they're already being used for, say, monitoring pasture growth, and I'm sure that's the same for other crops as well. So it's more easy to see those sorts of applications. But, I'm sure there are applications as well in animal breeding. And I think, as I keep saying, I think those are the most exciting and interesting things that we can innovate in. And that's one of the advantages, say, for the ARC Training Centre, that it brings together so many disciplines and potentially so many novel ways of looking at areas, and the way that we're using technology that can lead to breakthroughs in a completely different area. And I think that's super exciting.
Yeah. There's a question here around advancing predictions, genomic predictions for sustainability traits, and whether we need more data on experimental herds or farmer herds or both.
So, and I only really touched on this in my talk. So I do think that we need much more data that comes from commercial farms. This is because I think if we say we probably do have enough data from our research farm based in Gippsland, the Ellenbank Research Farm, that we could release a methane breeding value very soon. We're up to a 25% on a good day reliability for that trait, which is nearly at a level that farmers would accept. But the thing that I think is probably too much of a risk right now is to say that that would work in all the different environments and feeding systems that we have across Australia. So methane, I think, ultimately may be a bit of a G by E challenge, but we won't know until we've actually gathered the data from those commercial farms to what extent that is an issue. And it's a big area of research for us right now. We've got the Green Cow team that Boris Fazell and also Christy are part of, and I think that's a very important area for us right now.
You might have touched on it, but there's a question here about the biggest focus area in dairy farm genetics moving forward, but maybe you want to touch on anything else.
Yeah, right now it's the most important thing that we get right. And it's not necessarily that cows are the problem. It's just they're such a good part of the solution because methane is such a potent gas. So the quicker that we can use genomic selection and other methods to bring down methane emissions, the more we'll have done our part to contribute to this area. Yeah, that's probably enough. Yeah, thank you.
Sure. And I guess just to wrap up a final forward-looking question, more broadly, what do you think is one thing that you'd like to see more of from this next generation of scientists?
Yeah, I think, and I think the risk question was good. I think it's, during a PhD, it is an opportunity to take risks, and I would certainly encourage, people to our students to think about, things that could be really innovative in their projects. Obviously, a lot of the time, and I think it's probably a reflection of my career as well, to have the courage to put forward an idea and discuss that with your supervisors and to get that sort of feedback, and to appreciate that you may not necessarily have all the answers, but certainly, the idea generation it's going to be the most powerful way is just by putting together the best brains that we have. So I'd say, yeah, have the courage to put forward your ideas.
Yeah, thank you, Jenny. And thank you again for such a great seminar. I think you were really courageous talking about yourself so openly today, and it was made for a really nice science seminar. So thank you.